Hey guys, so in this video I'll be discussing something interesting. I've been thinking about this lately. What are some important parameters that govern the behavior and evolution of complex systems? There are many candidates that come to mind, like energy, entropy, symmetry. So basically, a system, as we know, over time it tries to reach an equilibrium state. In other words, it tries to maximize its entropy or minimize its energy. Or to put it in a better way, it tries to distribute the energy uniformly through the entire system. So that's kind of minimizing the energy locally, right? So basically, now the point is the understanding the interplay or the connection between these parameters is not as straightforward because entropy, there are many kinds of entropy. Transfer entropy, the flow of information in living systems, like when birds are flying, they need to communicate, like some information needs to flow so that if one bird changes direction, all the birds will understand what to do because they are flying by maintaining that pattern. So transfer entropy is something else. And there is entanglement entropy, there is which is entanglement entropy is something entirely different. It relates to black hole physics and information paradox. Then there is something called, but the example I want to discuss in this video, in this YouTube short, is it's called like the configurational entropy. So we expect if we have a system of two different gases, and we just leave them in the same container, over time we expect the gas molecules to mix because that's the equilibrium state, the maximum entropy state. But it has often been observed that polymers are just like connected chains, long chains, connected chains of molecules. Some they are used in, they are related to the DNA and all biological stuff. I don't understand that part well, but the point is that they are long connected chains, and if we keep two polymers, then they are found to spontaneously separate. It's called demixing of polymers. They do not mix, they demix by themselves. So you might think that demixing means they're separating out. So that means that's not the, globally, if you look at the system, then you can separate. That's not the mixed state. That's not the highest entropy state. But you have to think about it differently. Gas molecules are free particles. Polymers are not free particles. They're connected. They're linked chains. So if they're on top of one another, then they cannot vibrate freely. But if they demix and they're separate, then they can vibrate more freely, and they can access more number of microstates. Or to put it in less technical terms, they can vibrate through many more possible frequencies, many more possible position configurations. Like it can vibrate in many different ways, and each of this way corresponds to one possible microstate. And more the number of microstates, more the total entropy of the system. So even this demixing behavior, it's actually trying to maximize the configuration entropy. So entropy is always maximized. It's kind of like a fundamental law of physics, but it's important to understand like the logic, like what is happening in what phenomena. That varies from case to case. That's what I wanted to discuss in this video.